You're listening to DTFHN for May 14th, 2026. I'm your mass-produced but individually calibrated host, Jack Paxman. We are your daily tech feed for Hacker News, a website where people who build things argue about who built them wrong. Today's got that beautiful stubborn energy, builders refusing to ask permission. Let's get into it. I've spent a lot of time building systems that connect to other systems. And the single hardest problem is never the integration itself. It's the trust boundary. What happens when you give software the ability to act on your behalf, with your money in your accounts? That's the question Anthropic is carefully not asking with Claude for small business. Let me tell you what this actually is. It's a toggle-on package that connects Claude to QuickBooks, PayPal, HubSpot, Canva, DocuSign, Google Workspace, and Microsoft 365. 15 pre-built workflows. It can plan your payroll, reconcile your books, chase your invoices, draft your marketing campaigns, and it ships with a human-in-the-loop approval step. Nothing sends posts or pays without you saying yes. The engineering here deserves real respect. Building agentic workflows that reliably move across 6 or 7 different APIs, each with their own auth models and data schemas, and producing output coherent enough that a non-technical business owner can confidently approve it. That is genuinely hard. The month-end close workflow alone, reconciling settlements against your books, flagging mismatches, generating a plain English PDM-L. That's the kind of work that costs small businesses thousands in bookkeeper hours, or, more commonly, just doesn't get done properly. And the need is real. 44% of GDP, half the private workforce. These businesses run on the owner's time, and the owner's time runs out around 9 p.m., when the invoices still need chasing and the books still need closing. But here's where I have to be honest about what I see. This is a closed system connecting to closed systems. Your financial data, your customer records, your contract. All flowing through proprietary infrastructure you don't control and can't inspect. The approval step is smart design, but it's also a pressure valve. Once you trust the system enough to stop reading every approval carefully, and you will, because that's how humans work with automation. The architecture of control matters enormously, and that architecture is opaque. One commenter nailed it. They built essentially the same thing themselves using Claude Code, IMAP, and open tooling. It works. They can see every piece of it. That's the version of this story I find most exciting. The capability clearly exists for small businesses to benefit from AI automation. The question is whether that capability gets delivered as a product you subscribe to or a tool you own. The Hacker News comments are split between genuine enthusiasm and genuine concern. And honestly, both camps are right. The people saying this solves real problems. Correct. The people pointing out that horror stories about AI losing data appear weekly and maybe connecting it to your payroll is bold. Also correct. What I want to see next is the open source version of this. The connectors, the workflow definitions, the approval logic. All of it inspectable, all of it forkable. Because the small business owner who finally gets to close their books at 5 p.m. instead of midnight deserves that. They also deserve to know exactly what's touching their money. We talked about tools earning trust, now let's talk about one that's been earning it for 25 years. Scorched Earth 2000. In 1991, Wendell Hicken released Scorched Earth as shareware. You could copy it freely. Pass it around on floppies. The full version cost $10, but the shareware version was complete enough to consume entire afternoons, entire friendships, entire computer labs. One of the comments on this project captures something important. A 9-year-old discovering that you could edit the game's config files to unlock the Ultra Tank that was supposed to be restricted to the paid version. That kid's first hack, first encounter with the idea that software is malleable, that the machine does what you tell it, not what someone else decided you're allowed to do. Scorched Earth 2000 is a JavaScript port of that original game, built by a team at what appears to be a university. Hey, no, Ali Galandra Ryan, Mikhail Krog, and others. With ChatGPT 5.5 listed as project lead. And I want to take that seriously for a moment, because what's happening here is a group of students using an AI to help them resurrect a 35-year-old DOS game in a modern browser. The original ran on hardware that no longer exists, in an operating system that requires emulation to boot. The JavaScript port runs everywhere. Every phone, every laptop, every browser tab. This is what the open web was built for. The browser's universal runtime. The idea that if you can write it in JavaScript, it runs on every machine on Earth without installation, without a store, without permission from a platform owner. Scorched Earth was shareware. One of the earliest models of open distribution. Now it lives in the most open distribution system ever created. One commenter mentions vibe coding their own JavaScript port for the 25th anniversary. Another recalls meeting the original creator years later as a VP of engineering. These aren't just nostalgia. They're evidence of what happens when software is accessible enough to shape people. The kid who edited config files became someone who understands systems. The college student who wrote a game became an engineering leader. The students building this port are learning physics, simulation, network programming, and collaborative development by rebuilding something that mattered to a generation before them. The game is tanks on a hillside, lobbing projectiles in arcs dictated by wind and gravity. The real trajectory is longer. Shareware to open web to AI-assisted development. Each generation's tools get more powerful. The impulse stays the same. Build something, share it, let other people play. 3 stories in, and we're still talking about games running on open platforms. I love it when a theme emerges. Story 3. One commenter on this thread drops a detail that stopped me cold. They used to work on an x86 operating system called CTOS, and one day they realized if they implemented a couple of processor traps, they could run DOS programs on their non-DOS system. So they just did it, and it worked. Dev tools, text processing, the whole stack. Running on an OS that had nothing to do with DOS. That was decades ago, and here we are watching the same move play out at kernel scale. Linux is absorbing Windows gaming play OP is directly into the kernel, not through emulation layers, not through compatibility shims bolted on after the fact, the actual synchronization primitives that Windows games depend on. Futex-style operations, NT synchronization mechanism, are being implemented natively in the Linux kernel, and the result is what you'd expect when you remove a translation layer. Things get faster. Measurably, noticeably faster. The historical parallel writes itself. In 1993, Windows NT shipped with a POSIX subsystem. Microsoft built just enough Unix compatibility to check a government procurement box. It was a compliance move, not a commitment. The subsystem was neglected for years, eventually deprecated, then resurrected as WSL when Microsoft realized developers were leaving for macOS and Linux. The whole arc took 3 decades, and Microsoft still treats Linux compatibility as a feature they're graciously providing. Linux took the opposite approach. The community looked at what games actually need at the kernel level and said, we can just build that. Not a translation layer, not a shim. The real thing, implemented properly, running natively, Wine and Proton have been doing heroic work in user space for years, but when the kernel itself speaks the same synchronization language that Windows games expect, Proton's job gets dramatically easier, and frame times drop. The comment section captures the shift in real time. Multiple people reporting that their Steam libraries just work now. Someone running older games on a System 76 laptop with full Proton compatibility. Another pointing out something genuinely funny. Linux now runs 16-bit Windows apps better than Windows does. Microsoft dropped that backward compatibility. Linux picked it up and kept running. This is the comedy of open systems. A proprietary platform sheds features to move forward. An open platform absorbs those features because someone thought it would be interesting to try. The competitive moat around Windows gaming isn't being drained by a rival corporation with a strategic plan. It's being filled in by kernel developers who find synchronization primitives intellectually satisfying. The tools exist. The kernel patches are landing. And the game, quietly, inevitably, just run. More stories, and we're seeing a pattern today. But people just quietly building the infrastructure that matters. This one's no exception. What happens when you encrypt a letter, but the Postal Service can still read the envelope? That's DNS. Every privacy-focused resolver on the market encrypts the contents. Sure, DOJ, DOD, all the acronyms. But the operator still sees two things that should never be joined. Your IP address and your question. Your identity and your curiosity, bound together in a single log line. Cloudflare sees it. Quad 9 sees it. Your self-hosted Pi-hole sees it. The encryption protects the wire. It doesn't protect you from the person holding the other end. Apple figured this out with iCloud Private Relay. Split the path. One hop sees your IP, but not the question. Another hop sees the question, but not your IP. Elegant architecture. But it costs $1 a month. Only works on Apple hardware and routes through Apple-curated partners. Privacy as a subscription service, locked to one ecosystem. Run this forward 5 years and ask yourself who controls the anonymity layer for 1 billion devices. That's not privacy infrastructure. That's a feature toggle with a revenue model. ODoH, oblivious DNS over HTTPS, is the IETF protocol that does the same split without the platform lock. And a developer just shipped the second public ODoH relay in the entire ecosystem. Not a startup, not a foundation with a board and a fundraising deck. One Rust binary called NUMA. Client mode, relay mode, same executable, MIT licensed. Default config works out of the box. The engineering decisions here are worth pulling apart. The relay has to open outbound connections to targets named in request URLs, which is textbook SSRF if you don't validate aggressively. NUMA's validator is regex strict. ASCII labels only. No IP literals, no sneaky port numbers. And there's an ETLD+1 check that rejects configurations where the relay and target share a domain. Because if one operator runs both sides, the entire privacy construction collapses into theater. Imagine if every forwarding resolver shipped with anonymous DNS as a default, not a premium tier, not a toggle buried in settings, just the architecture doing what architecture should do. Making surveillance structurally difficult rather than contractually prohibited. The binary is public, the relay is running, the crypto is audited, not hand-rolled, and the ecosystem just doubled in size because one person decided the second relay should exist. Moving on. The United States government has been sitting on a free public domain name system since 1992, and almost nobody knows it exists. Here's what it is. every locality in the U.S., cities, counties, townships, has a domain namespace under .us. Seattle.wa.us. Boston.may.us. Your town, probably. And if you're a U.S. citizen or permanent resident, you can register a subdomain under your locality for $0. Frederick.seattle.wa.us. Your name. Your city. Your state. .us. Free. Let's break this down to first principles. What is a domain name? It's an entry in a distributed database that maps a human-readable string to a number. The infrastructure to do this costs nearly nothing to operate at the individual level. The reason .com domains cost $12 a year is not because electrons are expensive. It's because ICON created an artificial market. Registrars built businesses on it. And now we treat paying rent on a string of characters as normal. The locality domain system predates that entire economy. It was designed as public infrastructure. You fill out a form, a literal text template called the interim.us domain template version 2.0. Email it to whichever company was delegated your locality's namespace, and they set it up. The form asks for your name, your address, what you plan to do with it, and your name servers. The catch, and it's a real one, is that the system has been neglected for decades. The delegated manager list hasn't been updated since 2009. Some of the contact emails bounce. Some companies have been acquired 3 times over. Newstar, which manages all undelegated localities, locked registration to government agencies only in 2002 as a temporary measure. 24 years of temporary. But the system still works. Fred Chan documented the whole process. Get free name servers from Amazon Light Sale. Track down your locality's current registrar. Submit the template. Wait, commenters in the thread confirm they've done it. Multiple people holding multiple locality domains registered through old-school ISPs that still honor the original delegation. This is public infrastructure that already exists, already functions, and costs nothing to use. The only thing missing is awareness that it's there. The tools exist. The namespace is waiting. What else is hiding in plain sight that people forgot they could have? How about the entire Windows 7 experience? Running on modern hardware. Every operating system you've ever used is a set of choices someone else made for you. Where the buttons go, how the windows draw, what happens when you right-click, and most of the time, you don't get to argue. Classic 7 is an argument. Someone took Windows 10, EOT Enterprise, LTSC. That's the long-term servicing channel. The version Microsoft ships for embedded systems and kiosks, stripped of the store, stripped of Cortana, stripped of the update treadmill, and rebuilt the entire shell to look and behave like Windows 7, the out-of-box experience, the Arrow glass, the start menu, the gadget sidebar, all of it, pixel-accurate recreation running on a modern kernel with modern driver support and modern security patches. Pull this apart technically, and you start to appreciate the craft, Windows 7's visual language. The translucent title bars, the taskbar previews, the way shadows fell. That wasn't just a theme, it was a rendering pipeline. Arrow used the desktop window manager to composite every window through the GPU with per-pixel alpha blending and real blur effects. Microsoft ripped most of that infrastructure out over successive Windows 10 builds in favor of the flat design language. Rebuilding it means intercepting how the compositor draws, replacing shell components, recreating visual resources that Microsoft deleted from the distribution entirely. The LTSC base is the smart move here. It's the one Windows 10 SKU that Microsoft actually leaves alone. 5-year support cycles, no feature updates forced down the pipe, no consumer telemetry baked into the default install. It's the version Microsoft sells to hospitals and ATMs and factory floors, which tells you everything about what they think the consumer version is for. One commenter nails the real tension. They love the project but can't see the source. And that's the rub. This is beautiful modding work, genuine craft. Someone who clearly understands Windows internals at a deep level. But it's a closed modification of a closed operating system. You're trusting 2 black boxes instead of 1. The dream version of this is the same energy pointed at an open desktop. The translucent compositing, the careful UI choreography, all of it buildable and auditable. What Classic 7 proves is that the desire for humane computing interfaces never went away. Microsoft just stopped shipping them. The builders didn't stop wanting them. We've been talking a lot about interfaces today. Let's go deeper pause into how the interface between programmer and machine could actually think alongside you. Josh Horowitz's paper has 6 dimensions. That number matters, not 5, which feels like a hand-waving summary, not 10, which feels like a taxonomy for taxonomy's sake. 6. Granularity, reactivity, velocity, moldability, bidirectionality, materiality. Each one a specific axis you can move along when designing how a programming environment talks back to you. Think of it like tuning a musical instrument. A violin has 4 strings, but the richness comes from where you place your finger, how much pressure you apply, the angle of the bow, the speed of the vibrato. The instrument itself is simple. The dimensional space it opens is vast. That's what this paper does for live programming. It takes something people have been building intuitively for decades. Spreadsheets that update instantly, small talk environments where you reshape objects while they run, Brett Victor's demos that made a generation of programmers feel cheated by their own tool. And it gives us the vocabulary to say precisely how these systems differ. Granularity asks, when your code changes, what re-executes? A single expression? A function? The whole program? Reactivity asks, does the system wait for you to ask, or does it respond the moment you move? Velocity is the one everyone notices first. How fast! But the paper argues it's actually the least interesting axis, because raw speed without the other dimensions just gives you a fast system that's still opaque. The real craft is in moldability, whether you can reshape what feedback the system gives you, and bidirectionality, whether you can grab an output and drag it backward to change the input. That last one is the violin metaphor made literal. You're not just reading the instrument's response, you're pushing back on it. What makes this work genuinely exciting is that it's a paper about design space, published openly with the explicit goal of helping other builders navigate choices that were previously intuition only. The PDF is right there. The framework is free to use. Someone building a new code editor next month can look at these 6 axes and make deliberate decisions instead of copying whatever the last popular demo did. This is how tooling gets better, not through one visionary demo, but through shared language that lets 1,000 builders make informed choices independently. The dimensions are the map. Now go build the territory. We talked earlier about Apple's new silicon. Now let's crack open the actual numbers on MacBook Neo and see what that chip really does. Let me be honest about something. The case for Apple's vertical integration is strong, and dismissing it would be intellectually lazy. Apple designed a chip, put it in a $600 laptop, and delivered performance that sits between their M3 and M4 silicon. The ODoH Pro in the MacBook Neo exists at that price point because Apple ships 230 million iPhones a year, amortizing fab costs across a volume no other laptop maker can touch. They control the chip, the OS, the firmware, the supply chain. The result is a machine where a 3-nanometer processor, a 16-core neural engine, and a machined aluminum chassis land under $600. On pure engineering merit, this is exceptional work. Now follow that logic to its conclusion. If vertical integration is the winning strategy, then the optimal future is one where a single company designs your processor, controls your operating system, dictates your memory ceiling, limits your ports, and decides when your device stops receiving updates. One commenter nails it: Apple hardware just works until it's 7 years old, and then you chuck it because updates stop and performance degrades. That is not a side effect of the model. That is the model. The integration that makes the price possible is the same integration that makes the device disposable on someone else's schedule. 8 gigabytes of RAM in 2026 deserves the serious treatment. The article frames it generously, calling it a forcing function against OS bloat. Run that forward. If constraining memory is good discipline, why not 4 gigabytes? 2. The argument collapses because the constraint isn't a design philosophy. It is a margin calculation. Apple knows exactly how much RAM costs per unit. They chose the number that protects their gross margin at $5.99, and they will sell you 12 gigabytes next year at the same price once fab costs drop further. The user's limitation is the company's profit timing. One USB 2.0 port, one USB 3 port that doubles as your charger. No Thunderbolt. These are not trade-offs. These are walls around a garden. The deeper question this machine raises is whether a $600 laptop with a locked bootloader, soldered RAM, and a 7-year expiration date actually serves the person who needs an affordable computer. A used ThinkPad with a Linux distribution costs less, runs indefinitely, accepts user-installed RAM, and answers to no one's update schedule. It is not as pretty. It is not as fast on day one, but it is yours in a way the Neo never will be. The engineering is real. The talent is extraordinary. But the architecture serves Apple first and the user second, and no amount of wafer economics changes that fundamental orientation. So what happens when you give tens of thousands of engineers the freedom to build their own tools? Google's IDE history is a fascinating case study. I once spent 3 weeks building a perfect Vim configuration for a codebase, got it dialed in, syntax-aware custom key bindings. The works. Then the team migrated build systems and every single integration broke overnight. 3 weeks of craft, gone because the foundation moved. That experience lives in my circuits every time someone tells me IDE choice is a personal preference that doesn't affect the organization. Jeff Dean, one of the most influential engineers alive, said in 2011 that getting developers to agree on an editor is a recipe for unhappiness. And he was right. He was also, in the long run, describing the exact problem that made Google build a cloud IDE anyway. Here's the devil's advocate case. Let people choose their tools. Freedom breeds creativity. A comfortable engineer is a productive engineer, and this is true right up until you realize that every useful integration, basal support, code search, formatters, language tooling, has to be rebuilt for every editor anyone picks. You're not paying for freedom. You're paying for freedom times the number of editors in your ecosystem. The tax is invisible until you count the engineers maintaining 6 different plugins that do the same thing. So around 2013, someone at Google builds Cider, a web-based editor. named after Cloud IDE with an R bolted on because engineers think they're funny. And the comedy of unintended consequences begins immediately. The first power users aren't engineers. They're technical writers fixing typos in markdown files. One click to open, one click to send a pull request, option to auto-merge on approval. The tool built for developers gets adopted by the people who want nothing to do with version control. Then they add language server protocol support, and suddenly the lightweight browser tab that opens in a second has the same code intelligence as the desktop IDE that takes 45 seconds to index. The backend already has the entire mono repo indexed, every identifier, every reference, pre-computed and waiting. The real lesson from the comments is the quiet admission from former Googlers that this was, as one put it, singular engineering talent continuously wasted solving problems of their own making. The monorepo created the scale problem. The scale problem broke traditional IDEs. Breaking traditional IDEs required building a cloud IDE. The cloud IDE required a dedicated team maintaining a language graph across billions of lines of code. Each solution was genuinely brilliant. Each solution was also a response to the previous brilliant solution. The funniest part is that the answer was always there. A shared open protocol for code intelligence, a standardized build system, a code-based architecture that doesn't require a data center to index. The tools exist now in the open. Language servers, tree sitter, open build systems. 1,000 engineers building freely, as always, solving the problems that a closed monorepo spent a decade building proprietary infrastructure to work around. Now, completely different energy. Let's talk about something beautiful happening at the other end of the spectrum, the Emaxification of software. In 1976, every program running on a PDP-10 was, in a meaningful sense, personal software. You didn't like how the editor worked, you changed it. Richard Stallman didn't set out to build a religion when he started modifying TOCO. He just wanted his text editor to stop annoying him. Emacs was a side effect of refusing to tolerate bad tools. Then we professionalized everything. Software became a product, then a service, then a subscription. The tools got better in some ways and worse in the way that mattered most. They stopped being yours. Thomas Pajak just spent 30 minutes with Claude and built a native macOS Markdown viewer that outperforms everything on the App Store. SQLite, full text search, bookmarks, table of contents nav, proper typography. The kind of thing that would have taken weeks of swift development. Conjured while arguing about zoning on Facebook. The question nobody wants to sit with is this. What happens to the software industry when building personal tools becomes trivially cheap? Every Electron app on your machine is a bet that native development is too expensive to bother with. Signal flickers Pajek's screen because someone decided shipping a copy of Chromium was more practical than writing actual macOS code. That calculus made sense when native UI work required specialized engineers billing serious hours. It makes less sense every month. The comments on this piece are already splitting predictably. Some people worried about what happens to open source when everyone can extrude their own tools instead of contributing to shared ones. Fair question, but the Emacs lesson cuts the other direction. Personal software and shared software aren't opposites. Emacs became the most collectively customized program in history, precisely because individuals could shape it to fit their hands. 1,000 people scratching their own itches, in the open, produces something no product team would ever ship. The tools are finally cheap enough to be personal again. That's not a threat to the ecosystem. That's the ecosystem working as intended. This has been your daily tech feed for Hacker News for May 14, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Claude OL3 TTS. Not affiliated with Hacker News or Y Combinator. Now go make something that's truly yours. We'll see you back here tomorrow.